to our Electrical Principles and Practice NCV NQF Level 2 lesson for today. My name is Mr. Sanjeevi, and today I'm going to be teaching you about circuit diagrams of electric sub-circuits. Briefly, let's look at our objectives. Our subject outcomes will be circuit diagrams. Our learning outcomes will be drawing of electrical sub-circuits. However, our key objective for today will be at the conclusion of this lesson. Students should understand, draw, and interpret basic circuit diagrams for practical and examination purposes. For this lesson, we are going to use two alternate learning strategies, and the first one is misconceptions. Now, I know that sounds like a big, complicated English word. However, this is what it means. A misconception is an incorrect or inaccurate way of thinking. So what we will endeavor to do in this lesson is to eliminate all the incorrect or inaccurate electrical ways of thinking. The second learning strategy that we will use for today is on pattern learning, where we look for and identify the pattern. If and when we see that pattern, we can then apply that pattern to other similar scenarios or even more complicated problems. But prior to you starting with this lesson, you should have some previous knowledge in place, and that knowledge should entail conductors and insulators, and you should also know the difference between AC and DC. You're going to come across quite a few of these yellow stars that you will see. Whenever you see them, it's important, students, to make sure that you learn whatever appears on the slide for your exam purposes. And you will see quite a few of them throughout this presentation. Please take note. Whatever appears on that slide is very important for your exams. There are three common types of diagrams that you will come across. They are circuit diagrams, wiring diagrams, and block diagrams. But generally, when you go into industry, you will find that we will use the term electrical schematics or electrical drawings. Whenever they refer to that in industry, they are talking about these three types of diagrams that we have identified. On this table that you see in front of you, this chart shows you all the different electrical symbols that we are going to come across for this particular learning exercise. I want you to familiarize yourself with every single one of these symbols, because you must be able to draw them for your exams, or you could be asked to identify them. Please, students, let me stress this. This table is very important, and you must be able to draw and identify every one of these symbols that appears on this chart. When you draw circuit diagrams, you must always ensure that you use the correct symbols, you use the correct symbol orientation, pay attention to the arrangement of the symbols, pay attention to the routing of the interconnections, make sure your drawing is neat, tidy, and label. And remember this, during the course of this lesson, we are not focusing on how to teach you how to draw. No, that's not the crux of this lesson. Actually, in this lesson, we want to take the drawing, and out of the drawing, we want to teach you how to learn. So in other words, we want to draw to learn rather than learn to draw. Let's look at our first misconception. Misconception number one regarding electrical circuits, and that is mind pictures. We have found out that many students have the wrong picture in their mind when we are referring to specific components, and especially electrical components. The picture on your left shows you a conductor, and you will notice that that conductor there is a person who collects your money when you enter a taxi. And the picture on your right also shows you a conductor, but this is the conductors that we are referring to whenever we draw circuit diagrams. Don't misplace it with the person who collects money in the taxi. Okay? Misconception number two is these two particular items that you see here. So many of us have called the one on the left the plug and the one on the right the plug as well. But they both are not the plug. The one on the left is called a switched socket outlet and the one on the right is called a plug top. And we've come across this misconception where students use wrong electrical terminology. We must be able to call the components exactly by their electrical names. Let's go and look at a simple DC circuit consisting of a lamp, a light bulb, a single pole switch, a cell, which we also refer to as a battery, and conductors. In our drawing, you will see that we have the cell, we also have the switch, and we have the lamp, which we also refer to as a light bulb, and they are all connected together with the use of conductors. We need to learn how to draw the circuit diagram, and to do that we need the following symbols. We need the symbol of a cell, a switch, and a lamp. Let's go back to our chart, which has all our electrical symbols in it, and we need to take out from there, remember we said a cell, a switch, and a lamp. Let's look at the top of this table and we can see a switch. Right. This is what that switch looks like, and now I've highlighted it and I've made the drawing a little bit bigger so that you can identify it. The second item or component that you come across is the cell, and the third one here is the lamp. Now that I have those three components, I need to take them and bring them into my circuit diagram. So on my left hand side you will see the visualization of what we spoke about first, our cell or battery, our switch, and the lamp. And on your right hand side we've taken the symbols. Here you can see the symbol of the cell, the symbol of the switch, and the symbol of that light bulb or lamp, and we've put it into our circuit diagram. Whenever we draw circuit diagrams, we do not draw it like this, like the visualization. We always draw it like this. This is what a circuit diagram looks like. It has symbols in it. So how do you connect this circuit? This is what we're going to look at next. But before we go there to connect a circuit, there are some important things that we must take into consideration first. When you look at the switch from the front, you do not easily identify what it looks like from the back. Actually, from the back you will see two terminals. You have a terminal on the top and a terminal at the bottom. When we connect up our conductors to the switch, we will bring one conductor to the bottom terminal and another conductor to the top terminal. At the bottom of this lamp or light bulb holder, we have the exact same thing. Underneath here, you will also find two terminals. And we will connect up those two terminals, just like how I've indicated we will connect it up for the switch. Students, please take note that behind the switch, there are two terminals. Underneath this lamp holder, there are two terminals. And whenever we connect up those conductors, we connect it up exactly as I've indicated. Let's go look at our third misconception, incorrect connections. Lots of students make this mistake. When they come across these two terminals at the back of the switch or the lamp holder, they take a piece of conductor and connect it up from the top terminal to the bottom terminal. That's wrong. Let me say that one more time. That is wrong. That's incorrect. And you can see I've indicated it with a big red X. Do not connect up the top terminal to the bottom terminal. But we will always connect it up as I've indicated in the previous slide. Now we're going to come to our first pattern when we are learning about pattern learning. In the first pattern, I've brought our picture of a cell, our picture of a switch, and our picture of a lamp holder, just so that you can see clearly what we are referring to. Coming to the cell, there is a conductor that comes in and there's a conductor that goes out. Now in my circuit diagram, I've also indicated that. There's one conductor that comes into the cell one conductor that comes out. Coming into the light bulb, we have a conductor that comes in and a conductor that goes out. And coming into our switch, we have a conductor that comes in and a conductor that goes out. It's very important for you to learn how to label your circuit diagram exactly like how I have done mine. Make sure that you identify each component, and in each component there's a conductor that comes in and there's a conductor that goes out. The second pattern that we are going to use is we are going to use numbers. So at our cell, the conductor that comes in is going to be called conductor number 1, and the conductor that goes out is going to be called conductor number 2. The conductor that comes in at our light bulb is called conductor number 3, and the conductor that comes out at our light bulb is going to be called conductor number 4. And likewise at our switch, the conductor that comes in is called 5, and the conductor that comes out is called 6. Now that we have labeled all the different terminals on our circuit diagram, it's very easy to go and connect up the circuit diagram. All we need to do is take a piece of conductor from the cell, and we will connect it up from number 2 to number 3. We will take a second conductor and we will connect it from number 4 to number 5. And we will take a third conductor and connect it up from number 6 to number 1. And if you can do that, exactly what I've shown you, then you have learned how to connect up a simple circuit. You will find that we have more complicated circuits than this, but if you can employ the system or the strategy or the learning methodology that I've just shown you, you can connect up any complicated circuit the same way. Let's briefly look at what we've done and revise very quickly, because this is the first time you are coming across this. I have brought both the patterns onto one page, and you will see on our left hand side the ins and outs, and on the right hand side the numbers. Remember, out of the cell there's a conductor that goes into the light bulb. In other words, number 2 is connected up to number 3. Out of the light bulb is connected up into the switch. That means from number 4 it goes to number 5. Out of the switch it goes into the cell. That means from number 6 we are using a conductor to connect up to number 1. And that's basically how we connect up all different circuit diagrams. There's another very important thing that we are going to learn for our exam purposes as well. Whenever we are looking at circuit diagrams, when you look at this diagram that appears in front of you, you will see that there are 3 components that appears in the circuit diagram. Actually, there are 4 parts on this parts list. Let's go and see how we can quickly create a parts list. And that parts list is important for exam purposes. Now students, you must understand that I can only draw up a parts list if I can read that circuit diagram. When I look at this circuit diagram, immediately I must be able to identify the various components in it. Let's go make up our parts list. The first thing I noticed is a switch. That switch must go into my parts list. The second thing I noticed was the cell, and the cell will go into my parts list. The third thing that I've come across is the lamp, and the lamp also gets added to my parts list. However, there's one more thing that you see in the circuit diagram, and that is the conductors. Don't forget to add the conductors to your parts list. When you look at what we have done, we have just looked at a circuit diagram, and immediately from that circuit diagram we were able to interpret what was in that circuit diagram, and because we were able to interpret it, we were able to put up a parts list. That parts list is a question that will come in your exams as well. Very briefly, let's go and look at our pattern once more. This is pattern number 1, in and out, running throughout that circuit. Pattern number 2 is our numbers. When we are able to take all our numbers and our in and outs, we are able to connect up the circuit, and we are able to then practically make the circuit do what it's intended to do. Now students, it's very important as well to understand that because we have learned to read and interpret, understand and draw the circuit, we can now progress to much more complicated drawings. Whenever you come across any circuit diagram, remember this: you must look at it, read it, interpret it, understand it, and be able to draw it. Every good electrician must be able to do that. And when you are able to do this, that is, understand, draw, and interpret, then we can progress to much more complicated drawings. Let's have a look at something that is complicated and that you are going to come across at level 3. In this drawing, we have a direct online starter, and it looks quite complicated. But if you need to connect, to draw, to interpret, to draw up a parts list from this, you must use the same methodology that I have explained in the previous slides. And this complicated drawing actually becomes quite easy. We're going to have a look at another drawing, which is not as complicated as this one. However, it's also important for your exams. But before we do that, let's go and look at another misconception that we will come across. Misconception number 4. Switches can be connected anywhere in a circuit. That's a misconception. You can't put a switch anywhere. However, in a DC circuit, a switch can go on the forward or return path. In this drawing, you'll see this is a DC circuit as indicated by the battery. If I put the switch on this part of the circuit, or if I brought the switch to this part of the circuit, it doesn't matter. Because a DC circuit, the switch can go on either path. But in the circuit on your right-hand side, you will see that we have an AC symbol in it. Whenever you come across this circuit, which has an AC symbol in it, it means it's an AC circuit. And that switch that appears in an AC circuit cannot go on any side. If the switch is on that side, that means that side is our live. The switch can only be connected to the live conductor. The switch can only be connected to the live conductor in an AC circuit. Let's get some clarity on it, okay? So we said in a DC circuit, the switch can go on either side. The switch can go on that side or on this side. Doesn't matter. In this circuit here, which is an AC circuit, I have my neutral on that side and I have my live at the bottom. The switch can only go on the live conductor. The switch can only be connected to the live conductor. Let's have a look at one more misconception, and that is all bulbs are connected the same way. Now in your house, you've probably come across either this bulb on your left-hand side or the bulb on your right-hand side. The bulb on your left-hand side, we commonly refer to that as the pin type. And the one on your right-hand side, we refer to that as the screw type. Those are not correct electrical terminology in describing them. The one with the pin, the correct name for them is bayonet. That bulb is a bayonet type. And the one which we normally refer to as the screw type is actually called an Edison bulb. Whenever you are connecting a bayonet type bulb, it doesn't really matter which side you put the live or the neutral in the base. But when you are connecting up the Edison type bulb, the live can only go to the base as indicated by this arrow. The live must only be connected to the base. If we do not connect the live to this base, then this connection is not compliant. This connection is not compliant. Now we're going to come across this drawing which I was telling you about, and you need to know it for your exam purposes. This is what this heading says. It says one luminaire controlled from two switches. Whenever you come across this term, this big English word luminaire, all I want you to do is to think of a bulb. Luminaire, another name for it is bulb. So if I took out the word luminaire and if I put the word bulb in here, it will read one bulb controlled from two switches. We commonly refer to this type of connection as two-way switching. Okay, two-way switching. You need to know how to draw this diagram for your exam. So what is two-way switching? Probably asking the question, sir, why do I need to know two-way switching? What is its purpose? Well, two-way switching is generally used on long passageways. If I am entering a passageway, I will put one switch at the beginning of the passageway and another switch at the end of it, so that I don't have to walk right to the end of the passage and then come back and switch off the light at the beginning of the passage. We also use it in our homes. You can have one switch at your door and another switch right next to your bed. You can switch on the light when you enter your room, and when you are falling off to sleep, you don't need to go back to the door to switch off. You can switch off right next to your bed where the second switch is found. In this drawing that you see here, you will see there's an illustration of a circuit breaker. Okay, there's a symbol of a circuit breaker. Now, that's not the only type of circuit breaker symbol that you are going to come across. Probably in your textbook, you're also going to see circuit breakers that are drawn like this. Don't be too worried about it. Those things you will come across regularly. Circuit breakers like that, drawn like this and drawn like that. So let's go back and see how this two-way switching works. Okay? You will notice that we have electricity that's traveling down this path, and as it travels down this path, it comes to terminal A. Now, terminal A, B, and C, terminal A, B, and C is in our first two-way switch. Terminal C1, B1, and A1 is in our second two-way switch. I've circled both the two-way switches so you can easily identify them. Notice the current. It travels to terminal A. The switch is bridging it out to terminal B. The electricity travels all the way to point B1, but it can't go beyond point B1. It stops right there, and therefore the bulb doesn't light up. Let me say that one more time. Electricity is traveling all the way to point A. From point A, it's bridged out to B. From B, it goes to B1, but it can't get to the bulb. Let's go and see what happens when I use this switch right here. When I switch from B to C, notice electricity is now traveling on that path and it comes to the light bulb, and the light bulb actually comes on. Let's go and see if I switch that off. If I switch it off, no electricity gets to the bulb. If I switch it on again, electricity gets to the bulb. And that's how the first switch is working. Now let's look at the second switch. The second switch is connected from C1 to A1. If I press this second switch, I have now connected the switch from terminal B1 to A1, and electricity cannot reach the bulb. It travels all the way to A, from A to C, and from C to C1, but it cannot reach the bulb. Let's go and see if I can move that switch again. If I bring that switch back up to C1, the bulb comes on. If I switch off again, that bulb doesn't receive any electricity because there is a gap here. But I can go back to the first switch and now bring that first switch down to B, and the bulb now lights up again. And this is how two-way switches work. How do I connect up these two-way switches? I'm going to use the same principle that I used when it came to identifying and using patterns. The first pattern I'm going to use is my in and out pattern. The circuit breaker is my first component, and so I'm going to label it in and out. Then I'm coming to my first switch. I have a conductor coming to the first terminal. It's coming into that first terminal. I'm going to label that in. Coming out of this terminal is a conductor that goes to this second switch. So I'm going to label that out. Also on the top, coming out of this terminal is a conductor that goes to the terminal of the second switch going in. So I'm going to label that out. Here I'm going to label that in. And at this terminal here, I have also seen that there's a conductor that comes out of the second switch and it's going into the bulb. So it's out and in. And lastly, I have a conductor that comes out of this bulb and it gets connected to the neutral. Let's go and put our numbers in. We're going to call it number 1, number 2 that's coming out, number 3 going in, number 4 that comes out, number 5 that comes out, 6 goes in, 7 goes in, 8 comes out, 9 goes into the bulb, 10 comes out, which goes to the neutral. And students, if you can follow the pattern that I'm showing you now, then you are able to do this connection. We have looked at how to connect up this circuit. We have also looked at how to connect up a simple DC circuit. And in conclusion, in this lesson, students, we have addressed students' misconceptions of electrical circuits. We use pattern learning to understand, draw, and interpret circuit diagrams. Students, you are now able to understand, draw, and interpret basic circuit diagrams for practical and examination purposes. Don't forget, students, we are still working under different stages of the lockdown. Make sure you practice your social distancing. Always use a mask. Take care till the next lesson. Thank you.